afternoon, everyone. So very interesting sessions. Now we switch from gas to coal, and something which is also core to us. Most of our energy is coming from coal. So let's talk about potentials, about what coal brings to us, how coal is can be seen as a transformation that is coming. So three things I will talk. Say when it talks to coal, let's not treat coal only as an combustion fuel. How do I change? Okay, fine. So let's not talk coal only as a combustion fuel, and coal comes with three parameters: coal bed methane, then coal to chemicals, and of course the carbon capture, utilization and sequestration. Now if you see these three terms as CBM, C2C, CCUS, they interfere at some boundary each other. They are not to be treated in isolation, or they are not the independent technologies or independent parameters. Of course, CBM is the great prospect nowadays, because you will be receiving, you can recover natural gas from the coal seams, and that natural gas can be converted further to useful products like ammonia, methanol, anything. Then coal to chemicals is a very promising technology. Gasify the coal, make the syngas, which is the base fundamental for making several feedstocks for the chemical industry, and it's a very versatile source of any chemical manufacturing industry. Like you can make methanol, acetic acid, ammonia, dimethyl ether, fertilizers, and so on and so forth. And when we talk about coal gasification making so much of the products, unfortunate part of coal gasification is it comes with the very high footprint of the CO2 emissions, and unless you have something to capture that CO2 and do the sequestration, I mean that these three triangle or these three parameters or the equation cannot be solved so easily. So I talk about three loops, as I have said. One is your carbon loop, wherein you are converting the carbon into the good useful product. Second is the hydrogen loop, which is the giving you the energy and which is again giving you feedstock or something like that. And third is your, of course, the reservoir loop, which is CBM based or something like that. And these loops are of course interconnected. We can talk about it sometimes later in detail as this, say for example, reservoir loop, wherein we are extracting the natural gas from the coal seams, from the coal bed methane, what we call. So we can have the role of CO2 as well into this, as enhanced CO2 injection can increase and replace the sites that has been taking out the methane from the pores of those coal seams. So these three are the fundamental technologies that we are covering in detail. Give you a very brief overview, not to take about times, what are the coal to chemicals when we talk about what we can do about coal to chemicals. So as I have said that when you gasify the coal, it will give you the syngas, and syngas can be converted to several chemicals. Let's say you can convert the syngas to methanol, and then methanol is again a fundamental building block for making the further chemicals like dimethyl ether or other fuels and feedstock or a solvent and so many things from there. The second important pathway what I am going to cover here is methanol to olefins. This is an extremely important process. Means once you have converted coal to methanol, you can convert methanol to olefins. So this is the great pathway to make the olefins, not starting from the fossil fuels but from the coals. And the third important pathway from the syngas, which is a indirect route, I would call, is a Fischer-Tropsch synthesis route. So either you convert the syngas into methanol, ammonia and chemicals, or you use it into the Fischer-Tropsch synthesis and directly produce the waxes, kerosene, jet fuels, diesel, and those kind of the fuels that you can produce. So it's directly coal to fuels, coal to liquids, and of course the hydrogen is one part where you have been doing the steam methane reforming of the natural gas to produce it. You can produce the hydrogen from coal gasification. The syngas, after that you use the reverse water gas shift reaction to convert all the CO2 into the hydrogen. Most of the hydrogen production in China is coming through the coal gasification route, so very important technology. So these are the fundamental routes for that, and if you see the role of now how the coal is there, how coal impacts that. So if you look the several pathways, let it be methanol to olefins, or you can even have the MTP process or the Fischer-Tropsch process. Everything, the gasifier is the core of all these technologies. Means once you gasify gasify the coal and come out of the gasifier, everything else can be converted, routed. Their psychometric ratios can be adjusted. The syngas can be treated further to remove whatever you want. H2S can be removed, CO2 can be removed. It can be conditioned further to adjust the CO2 hydrogen ratios. But the main crux is the gasifier, wherein you need to put a lot of oxygen, you need to put a lot of steam into that. And these reactions are a little bit of complex. There is a whole bit of kinetics and whole bit of chemistry associated with the gasification. And there are several technologies for gasifying the coal. The Indian coal is very difficult for gasification. This is a very typical characteristics. India has the 5th largest reserves of coal, but we are not able to exploit that due to its typical characteristics of having the very high ash content. And because of the high ash content, the Indian coal poses a lot of challenges to gasification, and that gives us the problems with respect to using the gasification technology for coal to chemicals or coal to fuels or coal to hydrogen or coal to olefins, or for that matter, all those pathways pose a little bit of restriction on that. So if you see this high ash Indian coal, very high ash fusion point, when you put the coal into the gasifier and subject it to a very high temperature, the ash starts melting also, and when ash starts melting, it deposits on the surface of the exchangers, it deposits on the radiant section, it deposits on the refractory lining, and that poses the heat transfer obstacles. You are not able to remove the ash from the system. So this entrained gas, entrained flow gasifiers, which is a very common and most mature technology for coal gasification, unfortunately cannot be used for Indian coal just because of its high fusion temperature and high ash content. So people have developed other technologies. Now from India context, I know that BHEL has developed this fluidized bed gasifier technology that is being tested. Now for this fluidized bed gasifiers, they operate at a slightly lower temperature, so your ash fusion temperature is well within the control. And since you are operating at a lower temperature, you are removing ash as ash, so you are not removing ash as a slag, or you are avoiding the slagging of the ash in the fluidized bed reactors, and this gives you the better control of gasifying the Indian coal, and this technology is most suitable for that. So multi-point CO2 capture is possible from the coal gasification. As I have said that this all coal gasification gives the highest CO2 emission footprint compared to any other technology. And the best part of this is that this CO2 can be easily captured. The cost of captures will be very low because this is the pre-combustion capture technologies. This CO2 is at high pressure. So the capture mechanisms are a little easier. You don't need amines. You can use the physical solvent processes, whatever Selectol, Rectisol, whatever that methanol based or some other physical solvent based, having the least amount of regeneration energy for those solvents. So the capture costs are lower. Capturing is very easier. You can capture it as volume. And when you compare the coal gasification process with CCUS, then it is very much attractive compared to then equivalent fossil fuel based processes or reforming based processes. And the most important part is what do you do with this captured carbon, and there lies the, again, one gap. One is the gasifier technology, second is the utilization of carbon. There are certain techno-economic feasibilities, techno-economic studies that can be conducted as to what crude oil price this coal gasification becomes most optimum. It depends on several environment, what kind of coal you are using, what kind of plant configuration, what kind of products that you are looking. And analysis can be done with CCUS, without CCUS. Without CCUS, of course, you will be defeating the purpose of environment protection and will be polluting more by utilizing the coal. So obviously more effort further is required on many fronts for R&D. Though we said that this fluidized bed is a technology suitable for Indian coal, more research is required, more proof of concept, more pilots that can come up over there. The capture intensification also we require some good attractive technologies for capturing carbon and utilization of that. And of course, we have lot many things about sequestration part of the carbon capture, about mapping of the reservoirs, creating a national grid, creating a pipeline of CO2 disposal, and making the centralized network. And unless those things are there and those maturity levels are increased, the coal gasification technology, though, offers an immense potential to convert it to various useful chemicals, various useful feedstocks. There is a potential available in the technology. There are tools and methods available. Technology is matured, proven, has been used at scale at various purposes. With little bit of investment into the R&D, some pilots and some sequestration mechanisms, I think that this will bring the very great potential for that. So we need to commit to implementing those kind of lessons learned over the over these studies and over the pilots that has been taken care. Lot many things depends on policy supports. Initially require a lot of subsidies, gap funding, carbon pricing, carbon trading. All these things will come slowly. Slowly the things will mature. The moment we talked about carbon capture, utilization, sequestration, the coal gasification technologies become most attractive and most competitive with respect to energy requirement, with respect to CO2 footprint, with respect to the product profiles that you can make, with respect to the competitiveness of the making the product at cost compared to the other conventional technologies. So I rest over here. I thank you very much for your patient listening. Anything is required, I am available for any questioning later on. Thank you.